Hi everyone, my name is Wayne Revo. I'm the Director of Marketing for EMS and Public Safety here at Zoll. Ever since we began selling equipment to EMS, we've been constantly challenged by just how tough and how durable is your equipment. The first product that we really had for the EMS marketplace was the PD 1400. And as you can see here, this one's in pretty bad shape. It actually survived a fire in the back of an ambulance. It worked up until the time that the battery became depleted. And as you can see from the top, the battery is fused into the battery housing here. So it's impossible to replace that battery, or that device would actually work today. This M series over here was actually too close to a heater. As you can see, the front is distorted, the knobs are melted, but it's still functioning perfectly. Finally, we decided to really test an M series and see just how tough it was. What you're about to see is a series of tests that we put a standard M series through. It's an older device that we took off the manufacturing line. We wanted to see how it would survive falling downstairs. We actually threw it out of the back of a moving vehicle, tossed it down a muddy hill, and finally off of a rooftop. So sit back, relax, enjoy the video, and see just how tough the equipment that you're selling really is. Our first test was to take a device that was manufactured on the manufacturing line, just like all the devices were. In fact, it's an older device, a monophasic device. We threw it down the stairs. In fact, I think this was the 11th or 12th trip down the stairs for this product. Tim Stever, one of the electrical engineers, then went over, put it into defib mode, charged it up, shocked, and then tried pacer mode, and everything functioned perfectly. Our next test was to throw it from a moving vehicle. We'd done it once at about 20 miles an hour, once at about 30. This time it was at about 40 miles an hour. We threw it out the back of the truck. Tim once again goes over, puts it into defib mode. We have a special adapter on here that allows it to charge. And as you can see, he charges it up to 300 joules, delivers the shock, and that worked fine even after being thrown out, as I said, at least 3 times at 20, 30, and 40 miles an hour. And then he cranks up the milliamps, and the pacer is performing as to be expected as well. Here we look at one of the technicians up on top of a muddy hill who is going to throw the device, and you'll watch it bounce down the hill. He was not gentle on this at all. This is the same device that has taken the hits down the stairs and out of the vehicle. We then threw it down the hill, and Tim will once again go over, turn it on, and check and see whether or not it's functioning. As you can see, it's starting to get beat up. It's starting to get a little bit muddy, but we did have an Extreme Pack 2 on and all the appropriate cables. And once again, after really abusing this thing, it's functioning just fine. Finally, we decided that we really were out to break this thing, so we took it up on the roof about 1.5 stories up at Zoll, and we threw the defibrillator off the roof, and as you can see, it landed in the dirt, and Tim ran over. It's starting to look pretty beat up, but he put it into defib mode and then down into pacer mode, and it continued to work. So at this point, we were wondering if we were going to be able to break this device. And once again, it's a standard device manufactured under our normal conditions on the manufacturing floor. And as you can see, it's a monophasic device, so it is an older product. So now we tried really desperately to break it. As you can see, I had no mercy. I threw it well into the air, onto the pavement from about 1.5 stories up. And finally, we had a defib fault 78. So the engineers took it back into the lab and decided that they would take it apart to see if their suspicions were confirmed. And defib fault 78 was caused by a cable that had come undone. Now I should point out that about several months ago, they had already taken steps to reinforce that cable in all of the devices that have been manufactured since that time. So if we had taken a new device off the line and done that same test with it, if it had landed the same way and everything had occurred the same, then that cable would have stayed in and it would have continued to function. So even in spite of us trying to break it, had we taken a new device, it probably would have functioned after we had done that. So after we were done destroying one M series, we wondered how it would do under a bucket of water. So we got a bucket of water, poured it over, and guess what? Paper got wet, but the device functioned just fine. As you can see, the messages are very clear on the display. Paper continued to come out. We got the zero CO2 sensor, check recorder naturally because the paper was soaked, but we were able to deliver a shock at 120 joules and the device functioned just perfectly. As you've just seen, we did some pretty nasty things to this M series. We would not suggest that you do this to your equipment, nor should you encourage your customers to treat their M series that way either. What this demonstration did for me, as I'm sure the video did for you, was instill a tremendous amount of confidence in the ruggedness and the durability of the M series. Remember, this was a device off the line in a standard Extreme Pack 2 with all the appropriate cables attached. Thanks for taking the time to look at this video, and good selling.